Hi, my name is Krupa, and
My name is Angela.
so for our final project, our topic is about move semantics. Not every resource transfer is a copy operation. In many programming tasks, the resource only moves from one object to another, emptying the source object in the process. Copy versus move. There is a difference between making a copy of an object and making a reference to an object. For example, when you relocate to a new home, you just end up having a new home after relocation. You don't have two homes with identical residents and furniture. In the figures below, you can see how moving an object to another object is different from copying one object to another object. Moving on to move semantics. The topic of move semantics is an interesting topic, but why would you want your programming language to support it? An answer to that question is because copying object is an expensive operation. It requires a lot of memory and a large number of CPU cycles, especially when large objects such as images, video clips, or large data files are involved in this. Move semantics allows you to avoid unnecessary copies when working with temporary objects that are about to disappear and whose resources can safely be taken away from that temporary object and used by another object. The semantics and former properties of this move semantics are a new C++11 paradigm to make code more efficient and simulate real-world situations more accurately. Or values and add values needs to be understood well enough for us to understand the concept of move semantics.
Moving on to R value and R value references. Move semantics relies on a new feature of C++11 called R value references. It is denoted by two ampersand sign, and they're named R value because they represent the right-hand side of the assignment. That is something you can assign from but can't assign to. R value references allows you to detect when objects are temporary, so you don't have to preserve the internal state. It allows for more code efficient use. In C++03, we couldn't move resources, we could only copy, and thus we couldn't reuse the resources. However, in C++11, because of move semantics, we can keep reusing the resources. R value references also tells you when it is safe to move data out of an object. Moving on to an example. The following gives an example of R value. Here, getValue function is an R value because the value being returned is not a reference to X, it's just a temporary object.
Moving on to L value and L value references. An L value is an expression whose address can be taken. It provides a permanent piece of memory, and that's why it's called a locator value. Conventional references are known as L value references because they represent things you can assign to. Here are an example of L value. Here we declare an integer a, and assigning a value 1 to that integer a, that's an example of an L value. In our second example over here, the getReference function returns a reference to a global variable. So it's returning a value that is stored in a permanent location.
Moving on to move constructors. A move constructor is like a copy constructor. It takes an instance of an object as its argument and creates a new instance based on the original object. Technically, you can write a move constructor without using an R value references, but most commonly it is written using R value. Move constructor is better than a copy constructor because copy constructor is much more expensive in terms of performance, since it must allocate dynamic memory and copy the source characters one by one. Move constructor also enables you to implement move semantics, which can significantly improve the performance of your applications.
And last but not the least, move assignments. A move assignment operator is the move counterpart of a copy assignment operator. Its job is to release the old resources from its argument. As you know, in C++, when you declare any constructor, the compiler will no longer generate the default constructor for you. We have the same situation over here. Adding a move constructor to a class will require you to declare and define your own default constructors. On the other hand, declaring a move constructor doesn't prevent the compiler from providing an implicitly generated copy constructor in the same way Declaring a move assignment operator doesn't inhibit the creation of a standard assignment operator. And now, moving on to our demo part of the project.
Moving on to the demo part of the code. Here we can see a C++11 version of code of implementing move semantics. We have a class move semantics which defines a default constructor, a copy constructor, and a move constructor. Basically, what this code does is it declares two strings of move semantics type, which has the default string Alan Turing was a hero, and it copies this string 1 and string 3 to string 2 and string 4 using a move constructor and by not using a move constructor. So it copies string 1 to string 2 using a move constructor and copies string 3 to string 4 without using a move constructor. Let's run the code and see how it looks like. So if you can see the first block of the text, before calling move constructor, both string 1 and string 3 has Alan Turing was a hero. In the next block of code, we can see we are calling move constructor and we're assigning string 1 to string 2. This makes string 1 as empty and string 2 as having the contents of string 1, which was Alan Turing was a hero. Basically, it moved the contents from string 1 to string 2 and left string 1 empty. In the third set of output, we can see that we're assigning string 3 to string 4 and we're not calling the move constructor. This invokes the copy constructor and causes move to have failed. In this, string 3 and string 4 both have Alan Turing was a hero. In other words, string 4 is a copy of string 3. To summarize, a copy constructor makes a deep copy because the source must remain untouched. The move constructor, on the other hand, just copies the pointer and then sends the pointer and the source to null. It is okay to nullify the source object in this manner because the client has no way of inspecting the object again. Move constructor is always considered better in terms of copy constructor because copy constructor uses pointers for transfers, and this requires managing the storage, either the heap or some shared memory, which should be unnecessary and might even defeat the purpose entirely. Transferring values in and out of the scope, that is using a move constructor, it allows efficient passing of values without making extraneous copies in the end. This thus concludes our presentation on move semantics. We hope you enjoyed it and understood what move semantics and how useful they are in C++11. Thank you.
Thank you.